Okay, so let's start. So, so in this session, we are going to look at the data design aspect. Last time we looked at user interface design. So likewise, another important aspect of when it comes to design is the data design. Now, before we get into data design, we have to look at, what do you mean by, database management system. And this figure shows you a very simplified database system environment, right? So when it comes to database management system software, so usually we will have uh, software to process queries, programs coming from users. So when users are interacts, so most of the time it could be a particular application, and then through that you are going to make the queries or programs to process it. Or else if it is a programmer, then as a programmer you can directly write queries. So we need some software to process those queries comes in. So when it comes to processing, so you have to access the database. For that, you have a separate software to access stored data. So when you say stored data, so there are two parts. That means the actual data as well as data about data we call metadata. So everything together, we can say this is the database system. So if you look at the traditional file processing and databases, so earlier what you had is what we call file processing systems. That means you maintain set of files, right? So the problem with that file processing system was you have separate files maintained in different departments. For example, payroll department, they have their own file, and the personal department, they have their own file, which means, similar data items, if you look at it, there are some differences, but most of the time similar data is stored in sometimes different formats in different places. So this create a problem with, redundancy. That means data is duplicated. For example, same name and addresses are put in different places, which means it will waste storage space. And then sometimes when you make a change, if you make the change in only one particular place, not the other, then data becomes inconsistent. And other problem is sometimes very difficult to adding new data as well as modifying. So with the applications, and then file structure will be the part of the code. So those are the traditionally we will have the problem with the file processing. But when it comes to database management systems, this will reduce data, duplication, as well as wastage is minimized, because data will be put into some logical format so that there are no inconsistencies happens, right? Now let's look at some database management system interfaces. What you mean by is how you could put the input. For an input, there are a lot of interfaces available. Now, for example, nowadays we could have speech as the input and output, web browser as the interface. So many of the time with the cloud computing and all, like we use web browser as the interface to interact with the databases. Then we have what we call the parametric interfaces, like that means already predefined set of queries are put. Now, for example, if you go to ATM, what we call the bank tellers here, you have a set of predefined set of queries, isn't it? So you go there, you put your uh, input, you enter into the system, and then you can decide whether you want to deposit money, withdraw money, check in the balance. Those are fixed set of queries. So these are called parametric interfaces, right? So you can use different keys to activate parametric queries. Then if you're an advanced user like a database administrator, then there are other facilities also you need. You need to create account, given different authorization, meaning some users are allowed to insert data only, some are allowed both input and modify, some are allowed to even the delete. So you have different what we call access. So you can grant different authorizations. Then setting the system parameters. So depend on the system, there are things that you need to change. So that is also another thing the database administrator look at it. And then change in the schemas, structure of the database, as well as access path. That means, for example, indexing. So what index to use and so on. For that, you need interfaces for the database administrator. Right. Now, if you look at the overall picture of the database management system, so this figure, we are trying to elaborate on the different components. So in the previous one, this is actually elaboration on the previous one, same thing, but more with more information. This is a simplified one. Whereas we start with the set of users. So if you go back here, so you see that it's more information is giving here. Now, for example, we have database administrators, casual users, application programmers, and parameter. So general users we call parametric users, like customers. So they execute only predefined set of queries, what we call CAN transactions, right? And then there are developers we call application programmers, and they use some application programs to access the databases. And then there are casual users like managers. Now they want to make the decision on an organization based on some facts. Now for that, they have what we call the interactive queries. And then we have database administrators. So they have data definition language, which we use to create database, as well as you can, create users, grant authorization, and so on. So those are the different ways of interacting the database. Now, if you're using application programs, then you have to have some pre-compiler to convert it to host language compiler to do this, to get into the database. Right. Now, if you look at how people interact with the system, we have data definition language. So for that, we have data definition language compiler, and then we have query compilers for casual users, and most of application programmers and parametric users. So we will have what we call the DML statement and DML, compilers. So there we will interact with what we call the data dictionary. So this is about data, and then overall executions happen with here with runtime database processor, which will actually access the real data. So all the things, if you have learned, in databases, for example, you might talk about the transactions. That means concurrent access to the database. Now for that, you need what we call the concurrency control, how to access, multiple users access same data item and so on. And then there could be failures. So we need to talk about the backups and the recoveries here. So that comes here, right? So this is actually a complete database management system and their interactions. Okay, any questions from this part? Okay, no questions. Then I have a question for the audience. Okay, what are the different interfaces available for database management systems? You can type in the chat. What are the different interfaces available for the users to interact with the database management system? Yes, Sajid, web browser is one. How about Gihani? Gayatri? Shamila? How about Prageet? So what are the interfaces we have just discussed in a couple of slides back? Ishad? Irshad? How about Nanduni? Okay, let me type the questions. What are the, yes, speech, Vikum, that's good. Interfaces available for the users to interact with the DBMS. So I have typed the question in case if you missed it. We got three answers from Ajit, Gayatri, and then the Vikum. Yes, web browser, yes. That means you have web interface to interact with the database. You can use speech as an interface to interact with the database. Nowadays, it's possible. The question was like, yes, database management system provide these interfaces. The question is like, what are the interfaces available? How do you people interact? Not the applications, not the applications. Yeah, so if I quickly go back, so these are the interfaces I have discussed. And then what you see here in the graph itself, these are the different interfaces, right? So you can use different way to interact with the system. So you can use what we call the application programs. You can write in queries, the commands, because database admission is in different interfaces to interact with the system. Okay, good. So let's move on to the next one. So when it comes to data design, there are many models we use. Now, for example, in here we will talk about the relational database modeling, but there are other models nowadays developed. Like for example, we have NoSQL systems. So that means sometimes you have schema-less modeling and so on. But here we are going to focus on what we call the ER model. So here we are going to look at entities and relationships. Right. Now, when we are going to create the database, before you create the real database, that you have to make a plan, like we plan any other thing, right? So this is called high level, what we call conceptual data model, right? So this is called conceptual data model. And what we get from this is the conceptual schema for the database. So there are many models like UML, and then we have what we call the ER, but ER is one of the commonly used technique. So ER could be used uh, for conceptual design of the database. So the output we call ER diagram, right? So usually when it comes to database design, and especially if you have more than 20 tables, it's advisable you to use some conceptual data modeling technique. So remember that for a simple databases, you may not be, you may not use a, modeling technique. But if it is a complex, like say you have 20, tables of the relations in your database, then it is highly recommended that you use some kind of a conceptual data modeling. Right. In ER models, everything is described as entities, relationships, and then the attributes. So let's look at, I hope that you have already done, right? Isn't it? Yes. Have you already done ER, or are you new to ER? You have already done, right? So I'm not going to spend too much of time, but I will briefly look at to cover, because I'm expecting to cover the basics. So I will briefly look at, but I'm not going to talk about a lot of examples. But I hope you have a good understanding of ER modeling technique. Good. Having said that, let me move to the next one. So in this one, actually, I'm using the Navathe's books, one of the popular database management system textbook. And there they have used one, one particular example throughout um, the book to explain different, concepts in database management system. And it's about a particular company. And here we are going to look at the description. So if you have already done this, you may already familiar with this. So the description start with saying that a company, you have a set of departments, and it says that each department, it has a name, a number, and a manager, right? Employee who manages departments, that means you have a manager. And then we also need to keep track of start date of the department manager, and then department may have several locations. Okay, next, each department control projects, and the projects can be described using a name, number, and a location. Then you have employees, and for employees, you are going to track employees' name, social security number, address, salary, their sex, and the birth date. And each employee works for one department but may work on several projects. We keep track of number of hours per week, and then employee currently works on each project, and then you keep track of direct supervisor of each employee. And then finally, we are also going to keep track of employees' dependents, and then you are going to keep dependents' name, sex, birth date, and relationship to the employee, right? So here is the whole description about the company. Right, so this is the ER diagram. So I hope you know how to come to this point, because what is capitalized here is we call entities. Those, now for example, if I take you, I can take you as a student entity, and those are the lecturers we can take as lecturer entity, and so on. So entities normally will put in capital case. We have used uppercase letters to represent entities. So you will see that we have department, project, employee, and dependent. So that is represented here: employee, department, project, and dependent. Right. Now, each of these entities can be described using a set of attributes. Now, for example, here we say department, you have a name, number, an employee who manages the department. Right. So we have a department, we have a department name, number, and then we have a manager. right? So it actually comes through one relationship. And we also say that the department may have several locations. So we have a different type of attribute we will use. This is we call multi-valued attribute. You have double ovals here to represent that department may in multiple locations. Right. Then likewise, if you look at the projects also you have a name and a number and a single location. So the projects we have name, number, and a location. Then we have employee, we have social security number, name, social security number, address, salary, sex, and birth date, right? So for that also you will see it here. So employee, you have name, sex, address, salary, social security number, and a birth date. Name is a composite, meaning there are several components here. That's why you will see like this, which means the name includes first name, middle initial, and last name. This we call a composite attribute. And then you will have dependents. Dependents, we will have name, sex, birth date, and relationship. So we have name, sex, birth date, and relationship. So those are called attributes. Now, once you identify attribute, you have to identify one of the attribute as a key attribute. We will call this later on. Key means a unique ones. Now, already we know that in department, name and numbers are unique. So you will underline these to represent that these are key attributes. Now, for the project also, we have name and a number. An employee, you have social security number. Unfortunately, for dependent, we don't have. So name, you cannot take it as a unique. You know that there could be some duplicate values. So which means this is a partial key. Whenever the partial key, the entity becomes a weak entity. So if you look at the representation, I will come to this point later on. So you have a double rectangle here. So double lines. It is because this is a partial key. The unique attribute or key attribute you have to, by combining the attribute, connect to what we call the identifying relationship with the employee. So you have to combine both social security number and name together to generate a unique key for dependent. Right, then you have to represent the relationships. Now, for example, it says we have a department, an employee who manages the department. So employee who manages the department, so that is one relationship here. So one of the employees actually manages the department. And we want to keep track of his start date because it's belongs to this relationship. You see attribute actually belongs to this relationship. So one of the employees works for, as a manager for the department. Right. Now, each department controls number of projects. So another relationship. Each department controls number of projects. So this is another relationship. So you will use this diamond shaped block to represent the relationship. And then we talk about employee works for the one department. They works for one department, so works for the department one relation. But it also says that may work on several projects. So employees works on several projects. So works on is another relationship. And then we have to keep track the number of hours. We say that we keep track of number of hours per week. So that is represented here. And they say we keep track of direct supervisor of each employee, which means another relationship we need to represent the supervision. So some employees supervise the other employees, which means we have a recursive relationship we call supervision. with the employee entity, right? And since it's a recursive one, we have to name the two sides. So this is, we represent the supervisor side, and this is we call the supervisee side, and it connects to the same entity type, right? And dependent, you have number of dependents with the employee, so you have dependent of, and this is dependent. And since this is a weak entity type, so this relationship is also weak, and the relationship type also weak. We have a double diamond shaped block we have here, right? The last one is you can put the relationship type. Okay, when it comes to relationship type, you have one-to-one relationship, which means one and one to many relationship, one to many, and then many to many. Right. Okay. Any question from this? No questions? Okay. I have a question then. How many entity types in this? So how many entity types are there? Okay, good. Vikum asked a good question. Thanks for asking the question. Now, what do you mean by weak? Now, if you take an entity, anything we can represent in the world, but if you cannot uniquely identify from the attribute it has, it becomes a weak entity. Now, for example, in this particular example, the dependent, what we had was name, sex, and then there are a couple of things, birth date, and the kind of relationship with the employee. So all these we cannot take as a unique, isn't it? Name, you cannot use the name as a unique attribute. Sex, birth date, relationship. So because of that, you know, what we have is a partial key. Name is taken as a partial key here. So then you have to, without existence of employee, there's no existence for the dependent, isn't it? Now there's no dependence in the database without employee record, isn't it? So because of that, so we will talk, say the dependent is a weak entity type. So as Edwin said, we have three regular entities and one weak entities. Okay, another simple question. We have got answers only from Ajit, Shanika, Vikum, and Edwin. I expect others also the answer the question, right? Otherwise, I will directly ask by your name and you are supposed to answer, right? Okay, here is the last question from this. So what are the key attributes in department? Okay, what are the key attributes? Yes, Prageet. We have Krishan Kumar, Edwin again. Okay, the correct answer should be there are two key attributes. There are two attributes we can take it as a unique attributes. So both name as well as number we can consider as key attributes. Yes, good. So let's move on to the next one. So actually, I describe everything, but now I actually going to go into details if any case, if you have not done this earlier. So entities, we call specific object or things that we will represent in the database. So employee, department, and project. So employee John Smith. So we call entities. Then research department, it's an entity. Product X project entity. And then attributes is the properties like name, social security number, address, sex, birth date. So those are called attributes. And then for each specific entity, you have a value for all these attributes. Now, for example, if you take an entity, we call employee, then employee entity can have name, for that value is John Smith. Then social security number, you have value of this 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you have address, the sex, and the birth date. And then for each attribute, you have a value set. Now, for example, if you take name, you know that it's a string, right? Then sex, for example, either male or female, we call enumerated, coming from 2, right? So likewise, you have for each attribute, you have a what we call the data type. So if you look at the types of attributes, there are simple attributes like social security number. It's a single atomic value. And then there could be composite. Now, for example, name, we had a couple of components. So we call composite attribute. You have several components. Then there are multi-valued attributes. Now, for example, if you say color of a car, nowadays you have multicolored cars, isn't it? So the color of a car, now we can consider multi-valued attribute. You can have multiple, colors. Like the location in the department, remember in our example, we had multiple locations. Then you have a derived attributes. So derived attributes, we will have, for example, you derive from another attribute. Now, if you take age, you can derive the age from, date of birth, right? So likewise, if you go back to our relation, there's a derived attribute called number of employees. So this number of employees you can actually derive from the department entity type. So this is possible. So it's called derived. And sometimes you have combined these, what we call the composite and multi-valued attribute. Now, if you say your previous degrees of a particular student, so that means you can have multiple degrees, isn't it? So you can have multiple degrees at the same time. So in the degrees, you get these degrees from different places, different colleges, universities, year, the degree, type of a degree, and the field of the degree. So that means you have both composite as well as multiple attributes are there. Right. Any questions from the type of attributes? Yes. Okay. Then I have a question for you. Give me a example of multi-valued attribute other than what is specified here. Give me example for multi-valued attribute. Good. Shanika, mobile number, yes. Okay, Prageet, sex, I don't think you can have multi-valued. I don't know. Yes, mail ID. The idea should be like you have a multiple of values. As Indivara said, maybe other names you can have multi-value. So if you have like multiple other names, then you can have yes. But usually name we take as atomic value. Yes, qualification, yes, we can take as multi-valued attribute. Good. Okay, let's move on. Now earlier we discussed entities and attributes. Now we are going to talk about entity types. When you put entities together, we call entity type. But individual is what we call entities. So for example, employee entity type, project entity type. And then attribute, for each entity you have to have a unique value. This is sometimes called uniqueness constraint, right? So key attributes is for each entity type, you have to have a key attribute. Remember this, very important. When you design the database in the ER diagram, you have to identify the key attribute. So all the key attributes we are normally underline in ER model, right? Now, for example, social security number of employee. So that's each employee you have social. This is like our identity card number. Social security numbers are used in countries like US because this book particularly US book. So they will have what we call the social security number. But sometimes this key attribute could be composite as well. Composite means you can have multiple values. So in US, for example, if you want to identify a car uniquely, you have to combine both number as well as state, right? And then you can have more than one key. Remember in department, we have more than one key attribute, right? Both name and number are key attributes. So you may have more than one key in the relation. Right. Now here are the symbols we use. Entities or entity types we represent using rectangular box like this. Weak entities we have double rectangle box like this. Relationships we have a diamond shaped block. Identify relationship we have a double line a block like this, right? So this is already we have seen in our design ER model. So here we have rectangle shapes for the regular entities, and for the weak we have double lines, and then we have normal relationships or regular relationships, and the weak ones are put it like this, right? Okay, and then we can represent attribute with the oval shape connect to the entity type, and any key attribute you have to underline it. Multi-valued attribute you have to have a double ovals, you have to use like this, right? Then composite attributes you will have different components connect to the attribute like this, so this represent composite, and dash oval we use for derive attribute, right? So if you go back to our relationship ER model, so here we will see normal regular attributes. Then we have key attributes. So these are key attributes. Here we have multiple, key attributes. And this is multi-valued attributes here, double ovals. And this here we have composite name, we have several values, and this is a derived attribute, right? And here we have dash line, so which is called partial key, attribute, right? So I hope now you have some understanding how to use this, right? So let's go back. Then you have the relationships. Now, for example, this is we represent binary relationship. Binary means for the relationship, there are two participating entities and you have either single line or double lines. This is called total and partial. I'll come to that point later on. And this is total and partial. And then you have some set of numbers. This is called cardinality. So this is represent one to many relationship. The idea here is one employee, right? Here, let's say one E1 connects with multiple E2, whereas one E2 connects with exactly one E1, right? So that's what we call the relationship, how you represent both participation and cardinality ratios, right? So let's look at the relationship in detail. Now, since we have learned the notation, the relationship means it relates to two or more distinct entities. Now, one example, John Smith works on product X. So we have works on, and then we have Franklin One manages, research department manages. So these are we call relationships. So relationships are we put on to groups, and then this is we call works on relationship, manages relationships types. So each individual relations we can put into relationship types. Then we have to define what we call the degree of relationship, right? Degree means how many entities are participating. Managers and works on, you have only two entities are participating, we call binary relationships. So if you go back to our example, so here we have works for, is it a binary relationship? A question. Works for, is it a binary relationship? Yes, isn't it? Because in works for, you have two entities are participating, right? What are the entities are participating for works on? What are the entities? Entity types are participating with works on. Works on, you have employee and project, isn't it? Good, right. So almost all these are, binary relationships. Right. So sometimes you can have more than one relationship type can exist with the same participating entity types. So look at our example again, right? So can you tell me what relationship types has more than one relationship type? What are the entity types which has more than one participating relationship types? Now, for example, if you take project, you have only one relationship, isn't it? But if you take both department as well as employee, there are two relationship types, isn't it? So you have works for and you have managers. Good. So you have for both employee and department, there are multiple relationship types. One is works for, another one is managers. Okay. So I hope you got the idea. Now there's a question from Vikram, what is a weak entity type? So remember that if the entity does not have a key attribute, that means you have no set of attributes you can take it to uniquely identify, then we say it's weak. So entity becomes weak. So weak entity, you have to have what we call the participating or identifying relationship, right? So in our case, the dependent is a weak entity type because there's no attribute we can take it as a key. So which means we have to identify owner or identifying entity type, so that is employee. So the relationship between employee and dependent, we can take it as identifying relationship. So we need to identify the entities, one with a partial key. So that means for weak entity type, you have to define what we call the partial key. You have used dash underlined, and then a particular entity that are related to identify relationship type. So in our case, dependent, for dependent or dependence of, we have to use both social security number and name as a key attribute. Okay, good. Any question from this? No questions? Okay, let's move to the next one. Maximum cardinality, right? This is cardinal ratios I have not explained in detail, but let me use here to get um, the explanation. So cardinal, maximum cardinality means for each entity type which has a relationship, we have to identify it with the maximum number of instances which actually participate. So there are three types. We have one-to-one relationships, one-to-many relationships, or many-to-one relationships. Or then we can have many-to-many relationship. So maximum number of instances that are participating. Okay, now let's give me an example. Let's take vice chancellor and a university. Let's say vice chancellor is one entity type, university is another um, entity type. So if you create a relationship in between, because each university you have a vice chancellor, what kind of a relationship you have? Is it one to one, or is it one to many, or is it many to many? Yes, Gihani said it's one to one. So what do you mean by one to one here? Can one of you explain what do you mean by one to one? What do you mean by one to one?
For the university, there's only one vice chancellor
Mhm.
and one vice chancellor for only one university.
Yes, exactly. So you have to take both sides. You can start with the vice chancellor side. You can say vice chancellor. Usually vice chancellor work for one university. Then you take the university side. You take one university. For that you have one vice chancellor. Good. So tell me, what is the relationship between a lecturer and the university?
One to many.
Yeah, it should be one to many. What do you call one to many? Can you elaborate more on what do you mean by one to many here?
One university has more than one lecturer, but one lecturer belongs to one university.
Okay, good. So you have to take both sides. When you take one university, you can have more than one lecturers, but there could be some university without any lecturers as well. Yes, there could be situations, but that's a maximum, right? We talk about maximum, but when you take a lecturer, maximally, maybe you take the number of, that is one, isn't it? So we call one to many. So what is the relationship between the lecturers and the students? Okay, good. It's called many to many relationship. Can one of you elaborate more on why you say many to many?
One student studied from many lecturer and one lecturer teach many students.
Okay, good. So that's exactly what you mean by many to many. So that is one. Then you have to specify the cardinality, minimum cardinality, meaning what is the minimum number of existence in the relationship, right? So sometimes there could be partial participation. Some cases it is mandatory, one no more. So this is called minimum cardinality. So minimum and maximum cardinality actually represent by drawing single lines or double line. So if it is a compulsory, if you are saying that at least you have to have one, then you have to have a mandatory constraint. If it is optional, then you can have a single line, right? So if I go back to ER diagram, now here you will see this is many to one relationship, which means if you take one department, there could be many employees. If you take one employee works only for one department. So that is what this means. Then both the sides, the minimum is if you take employee, you have to have a department, isn't it? So that's why this double line. Likewise, if you take a department, you have to have at least one employee. So that's why you have a double line here. So double means the total participation. Okay, let's look at the managers. It's one to one. That means if you take one employee, can manage only one department. And if you take a one department can be managed by one employee. So that's why it's one to one. But if you take this managers, not all employees are managers, the department. So that means only some of them. So that means minimum is zero. That means some employees are not managing the department. So this is a single line. And then this side department, you have to have a manager, right? So this is total participation, right? Now, can you explain the department and project? Likewise, the cardinality, maximum cardinality as well as minimum cardinality. Can one of you explain the relationship between department and project?
One department can have several projects, but one project belongs to only one department.
Good. And can you explain total and partial as well?
The project should have at least one department, so the participation is full, and the department may have projects or not.
Yes, exactly. Now, departments sometimes they might not have any projects, so that's why it's a one line. But if there's a project, you have a controlling department. So which means this is mandatory constraint. So this is single line, this is double line. I think good. I hope everyone understood this. Any questions? Any questions? No questions? No questions? Yes, then tell me what is the maximum currently between employee and dependent? What is the maximum hardly between employee and dependent? Yes.
One to many.
Some said many to many, some said one to many. What is the correct answer? According to the diagram, yes, these are the assumptions that you have to make if it is in the description, if it is not clear. But let's go back to our ER diagram. According to the diagram, yes, according to the diagram, it's one to many. Rashani, now you have to make assumption if it is not given. So what we assume here is if you take one dependent, then you have only one employee works in the company. But if you take employee, there could be many dependents, isn't it? Make sure you understand well. Okay, can one of you tell me what is the minimum cardinality? Yes. Can one of you explain me the minimum cardinality, the minimum number of participants, the total and partial participation?
Here, sir, the employee, not all the employees have dependents, but each dependent should have the employees.
Yes, anyway. So there are two things you have to remember here. The answer is correct, but the dependent, without an employee, there's no existence. So this should be anyway double lines. But remember, this is weak. So whether you have total or partial, you have to have double lines here. But I guess for any case, if it is a weak entity type, this will be a total all the time, right? Because without the existence of the identified relationship, there's no existence for this weak entity type. So it will be always double line. Okay, I think we'll have a small break, about 15 minutes, and then we'll continue around 11 o'clock. Okay, guys, then we'll have a break and we'll meet around 11. Thanks.